Welcome students for today's class. Today we are going to see intra-ISP routing, that is OSPF, and it belongs to your module 3, and you may get the short notes or short type of questions to write in your exam. So you have to keep in your mind that you have to write some around 5 marks of answer for this, and this is a very important topic. Next class we are going to do the BGP. That is also one important topic. So these things mainly I have seen in the question paper. It used to come for your short notes. So you can refer the slide for the notes and all. So let's see what is the meaning of your OSPF and how we can relate to our computer networks world. So now in the first slide, you can see making routing scalable. So here what is there, what do you mean by routing? Till now we have done many things about the routing and all. So here you can see main thing is about the routing, how you can make it as scalable, or you can say that how you are going to make it as very idealized. So that part we are going to learn over here. So here all the routers are identical and networks are flat. So these two concepts till now we have studied, but we cannot say that all these things are very true. Okay, because maybe the routers will not be scalable, not be identical also, and the network may be very clumsy. So that time how you are going to do the routing, and in that time we have got some of the algorithms. By using that algorithms we made our routing as scalable. So in yours, if you are going to consider about the scaling purpose of your routing, so what you are going to do is there will be billions of destinations. Okay, if there can be a billions of source, then definitely there can be billions of destinations, and in each moment we used to send the packets or messages from one place to another place. You know that we are using the mobile phone, we are sending the SMS, or we are sending the WhatsApp message. So all these things whatever we are doing, do you think there will be a count of all the message? No. So anytime in a very fraction of second we are receiving a hell of messages, and sometimes we won't get also because of traffic congestions and all. So how we can make all these things very scalable, that is the first thing to learn about that. So here also we can see one more thing also. If we have some routing tables, okay, wherever you can send or exchange the packets or messages, sometimes what will happen is the link will get swamped. So that time you need to get all the packets properly. It has to reach to your destination side. Then only you can call that your routing has been scalable. So to make all these things, we have to go for in some of the autonomy, where we have to use the internet concept in a very well manner, and we have to administer that. Yes, in this way we can send the message, or we should have the control over that message from one place to another place. Here you can see internet. What do you mean by internet? It is nothing but it is a network of networks. We know that what is the meaning of network. Network is nothing but where you are going to give the connections in between two devices, and you are going to send any message from one device to another device. That is known as your network. But if I will consider about the concept of your network of networks, so that means that within a very vast source, you are going to send to the you are going to send all the messages to the vast of your destination part. So that time you are going to use the concept of your internet. So this is one kind of your administrative autonomy, where you are going to use the concept of your internet to make the routing as more scalable. And also, if any network admin wants to have the control over the routing, then they can have their control only over their own network. Suppose I have one Airtel network, so if I want to have the control over that, then Airtel admin only can have the control over Airtel. Okay, so it doesn't mean that only one admin will have the control over whole of the network. That is quite impossible, because it is very vast. Okay, so moving towards one more next slide, you can see here what all are the approaches should be there from your internet to make the routing as very scalable. Okay, so here I have told you that one more thing is there, one more router which is known as your aggregate routers, that is also known as your autonomous system. That is the full form of your AS, that you have to remember. These all are going to work like your domains. So how you are going to work as your domains? So you remember one thing, there will be two concepts. One will be inter, another one will be intra. So here, if I'm considering about the intra, this AS is nothing but it is an autonomous system where it is going to work your domain. So if I will replace the word AS as domain, so I can say that it is nothing but it is your intra domain. So if I'm talking about the intra domain, then this autonomous system is going to work only within the same network, that you have to remember, because inter is with network within the network, but here only within the network you are going to use these autonomous domains. And also what all are the things it will have, as I told you that it is going to support your routers. Okay, so definitely it should run over the IP protocols. Okay, so it will have the same intra-domain protocols or name, because if you have connected with any of the organizations, then the host address you have to replace it with your IP protocols. So that time this has to be same, the routers has to be same, because we are using the concept of intra domain now. And also suppose if you have different domains, and if you want to have connect to the different routers and all, then the next host address or that network address you should have, the IP protocols you should have, and you are going to connect it also through that only. So next one, you can see we should have the gateway routers. Through this gateway routers, it will have the edges of each of the domains. Okay, why we are using the gateway routers? Because there will be the where we can make as a partitions, because we have to send the packets in such a way that there should not be any clumsy of the packets, or you can say there should not be any traffic of your packets. So that time that should be one edge. Okay, wherever you are going to have the edge, you can give the link in between your that some particular physical link to your routers. So that is nothing but that is known as your gateway routers. Okay, so you need to give the gateway routers. Then next you can see, if I will talk about the inter-AS. Okay, the two concept I told you, the first one is intra, next is inter, then it will be your inter domain. Then so inter means what? It is network within the network. It means that the routing concept, whatever we are going to apply. So here within the network, again network, we are going to apply this in autonomous systems, because it will be the routing among your autonomous systems. And here the gateways will perform within your inter-domain routing. Okay, and also the concept will be same like your intra-domain, but here it will work for your inter-domain routing system. You can see one diagram over here. I have some autonomous systems here. I have given the name as AS1, AS2, and AS3. And here you can see there are three networks, okay? And AS1 is particularly working over this network where the device routers are like, because it is a round, right? So that's the reason I'm calling it as your routers. It is not host. So here it is 1A, 1B, 1C, 1D. So similarly, I have given the names. Now, the intra-AS routing will work only inside the network. Okay, intra-AS routing will work only inside the network, a particular network. But what do you mean by inter-AS routing? Inter-AS will work within a network to within a network. Okay, it means that if you have a network here, multiple networks, and you want to communicate with each other, that time if you are sending any message or any packets or anything, that kind of communication will be known as your inter-AS routing. So here, whenever you will send the messages or packets, the first thing is you have to keep it everything inside your forwarding table, because in this forwarding table, it will send the packets properly to the next network, and there will be no traffic congestions. And also here you can see this forwarding table, it has been designed in such a way that it can configure your inter-AS domain also and intra-domain also. Both the things it will configure. Okay, so here in this forwarding table, suppose if I have determined all the entries about the intra-AS routing, so here I can write in this forwarding table, I can write all the entries for your destinations, who is going to the which destination, that kind of entries I can make it over here. And now one more side is also there, where I can make the inter-AS routing entries. So here the external destinations, if it has been mentioned, I can mention that one in another side. So in this way, it is going to be managed. So now you can see, suppose how we are going to work within this network. and if we are using the intra-domain forwarding. Okay, so how you are going to send the packets from one network to another network. So here suppose the router here in this network, that is AS1 network, it will receive some of the datagram as it is a network layer. So here I have used the datagrams. Okay, so here what is happening, this is a network, and here inside this AS1 I have sent the datagram which is outside of the AS1. I want to send like that. So if I want to send, then definitely it will be in the concept of your inter domain, right? So that time what I'm going to do here, it has to be received because he is going to send the packets as the datagram has to be sent, right? So here what is happening, you can see the point over here. The router should forward the packet to the gateway router in AS1. But which one? Where it is going to forward? Because I told you that the gateway router will be presenting inside every autonomous system, in every AS, in every domain. So whenever you want to send any packets from your network to other network, that time you need to cross your gateway router, because it will have a bridge over here where it can check it properly the packets and it can send to your other networks. So now how you are going to send? So here as I'm going to send to the other network, I have to utilize the concept of inter-domain routing. So here what I'm going to do, I have to learn which destination will be reachable through my AS2, because here this is one network, this is another network. You have to find out, if I want to send from this AS1, which destination will be very reachable, AS2 or AS3. That is the first thing we have to find out. Next point will be, you need to propagate which one will be the reachability information to all the routers in AS1. It means that you have to propagate all the datagrams in such a way that it has to find out all the information whatever is present inside your routers. So in that way, how you are going to find out? So here some of the concepts are there which will be very commonly used in your intra-AS routing protocols. That is, one is like routing information protocol, because through this only we can decide through which gateway router we can send. So here that kind of routers information this protocol used to give. I told you this RIP concept is also there in the syllabus, that also you can see over here. So here routing information protocol, that is also known as your RFC 1723. It is a name of your protocol which commonly used for your intra-AS routing. Okay, and what is the work of that? We have already done the distance vector. In this distance vector, it will exchange all the packets from one network to another network. Sorry, it is as it is intra, so within the network, so within every 30 seconds, so it is going to send, it will have all the informations about the protocols, and it can exchange all the data packets within the network in every 30 seconds of time. And it is not widely used because it is a intra-AS routing system. Okay, there is one more routing protocol is there which will be referring towards your gateway, that is known as your EIGRP. That is nothing but enhanced interior gateway routing protocol. So here what will happen, this is also based on your distance vector algorithm, and also it will be formally, it was used for your Cisco proprietary for decades, where it was open in year 2013. The more description about this, it is not related to this one. Only you need to remember the routing protocol name, which one is going to utilize for your gateway, that is EIGRP. There are many routing algorithms are there, which in detail you have to learn. Whatever is there in your syllabus, according to that you can learn. For your syllabus, only RIP and OSPF is available. So OSPF is also one more gateway where the full form will be like open shortest path first, and this is also useful for your, if you are having any, like if you want to send any protocols, if you want to find out any gateway protocols, here also it will be helpful. And but this follows your link state routing algorithm. This is not distance vector based, this is your link state based routing algorithm. Okay, so now if I want to go for your OSPF, because that is also one concept which is present inside your syllabus, you should know about this concept also. This is nothing but open shortest path first routing algorithm. Why it is open? Open in the sense publicly this routing algorithm is available. Anywhere you can apply and you can get the answer. And also I told you that this is based on your link state algorithm. So link state algorithm in the sense how it is going to be working out. So this can be again one more 5 marks of question. No need to describe more in detail. 5 marks like a short notes you can describe. So here how it is going to work out, in each router, it will flood the link state advertisements, okay? Link state advertisements in the sense, you will have two types of protocols, right? So that is your TCP, another one is UDP. TCP is nothing but it is your connection oriented protocol, and UDP will be your connection less protocol. So whenever if you want to connect directly towards your TCP or UDP, that time you have to have the internet protocol link. So how you are going to find out this internet protocol link? Suppose if your router is if you are using a router to send the packets from one place to another place, and then that time it found that I'm not getting any my destination point. So what it has to do? It will advertise. Okay, it will advertise that I'm not getting where will be the destination part. Fine. So that time what it will do? It will use this link state advertisement concept, and it will flood over full of the networks that the destination value is not getting up. That time all the routers within your entire autonomous system, it will just try to find it out. So that kind of concept is present inside your OSPF, and through that only it will get your destination value or destination point, and it will send the and then it will flood all the messages towards that. And also suppose in sometimes it will have the multiple links. If it will have the multiple links, then definitely if I want to measure my cost or bandwidth or delay, definitely it will vary. Okay, because if I'm sending one packet some 30 milliseconds of time over the network, and in the same time, suppose instead of one packet I want to send 100 packets, then I can assure you that my 100 packets may not be reached towards your destination side, because that time what will happen, my packets bandwidth is not that much of more, like bandwidth in which channel I'm sending, that will not be more, but packet number of packets is more. So if the number of packets are more, then that time you can say that definitely there will be a delay of your in your destination side, because the packet will not reach in that particular time period. So that is the reason we can say that if there will be the multiple links, then definitely the cost metrics will vary according to your bandwidth, time delay, and all, and also latency. One more thing is there, as we know that each of the router will have the full topology. Topology in the sense, you know that we have the concept of topology, that is bus topology, point-to-point topology, mesh topology, star topology. So you can see that in any of the network, if you will see properly, then all the networks will have one kind of the topology. Okay, so and in each topology there will be there will be one routers. Okay, which will be using the Dijkstra's algorithm to compute the forwarding table, or maybe they can use the like Bellman-Ford algorithm to find out the shortest path, like all these things, because the routers will have the full topology concept or networks, where it is going to use this kind of algorithms to count or to compute all the forwarding table data. And how you are going to provide the security towards your OSPF. Here, all the messages will be very authenticated, because it uses the malicious intrusion algorithm, where it can prevent all the unauthenticated data to send from one place to one source to an destination site. So now one more concept is there, hierarchical OSPF. So now what is the meaning of that? It is nothing but, here we have seen the two levels of hierarchy, how we are going to send it. We should have the local area networks and also the wide area networks, and also you can have the backbones. Okay, you can see over here, if you see properly, you can see everything is looks like your tree structure, where the routers has been connected towards your local area network routers like a tree structure. And here what will happen, see my as my diagram shows you here, you can see the area 1, that is nothing but my local area 1. Here this is my local area 2, and here this is my local area 3. and all the routers has been connected with each other. This is my internal routers. Okay, as it is present inside my local area networks, all these things will be my internal routers. And here one more network is present in the blue color, and that there are some three routers are there. They are known as your backbones. So now what happens here actually? So if you want to advertise that you are not getting of any destination side or source side or where to send and all, or any gateway informations or any problems if you are finding out, then you can just advertise it by using the link state algorithm. And after that it will just flood all over the networks or in the backbone, and then you will get your data whatever you are wanting for. Next thing, each node will use the area topology or any kind of topology if they know the directions that where it is going to send the data or the packets. So this is a hierarchical OSPF where it can send all the packets in the tree structure manner, and it can send to all the nodes. And also here you can see this is known as your area border routers, because you can see this is just in a border of your local area networks and the backbone. So what this area border routers will do, this one will find out the distances to the destinations within its own area. Okay, and also it can advertise about the backbone. Once the backbone informations are present over here, it can provide to this local area networks, and it can say that yes, I can get the informations from the backbone side. And also what the local routers will do here, they will flood all the link states in this area itself. They cannot forward to any other networks because they are within the local area networks. And also here you can see they can compute all the routing forwarding tables or routing datas and all within this area itself. It cannot forward the packets outside of the area, because this is inside your area 1 and within a local area networks. And here what this boundary router will do, it will connect with all the autonomous systems, because here within this router maybe one more network can be connected, and that can create your AS, right? So here according to that, all the boundary within by the use of your boundary routers, all can create all the AS and they can connect to each other. And what about this backbone routers? This is boundary router, the first one. Then the next thing will be your backbone routers, and this one will run only the OSPF limited to the backbone. They will not run all the things whatever is coming towards their backbone routers. Only they will execute or run only the OSPF limited things, because that is OSPF is nothing but open source open shortest path. So only they are going to utilize over the OSPF limited versions. Okay, so this is all about your OSPF.